Have you ever wondered about the invisible shield that protects us from the sun's harmful ultraviolet rays? This silent sentry, known as the Earth's ozone layer, carries a monumental task. It is our planet's own sunscreen, warding off radiation that could wreak havoc on all forms of life. Its story is a fascinating blend of exploration, understanding, crises, and solutions, a narrative that intertwines with our own survival. This is the story of the Earth's ozone layer, a captivating tale of discovery and scientific endeavor. Our journey begins in the late 19th century with a French physicist named Charles Fabry. A man of curiosity and intellect, Fabry was intrigued by the Earth's atmosphere, more specifically by the mysterious spectrum of the sky. He was determined to decipher the secrets hidden in the colors of the sunset. Fabry was a pioneer in the field of spectroscopy, the interaction between matter and electromagnetic radiation. This was the tool he would use to unlock the mystery. He developed an instrument known as the Fabry-Perot interferometer, a device that could measure the wavelength of light with extraordinary precision. With this innovative tool, he set out to study the spectrum of sunlight as it passed through the Earth's atmosphere. As he analyzed the data, he discovered something unexpected. There were certain wavelengths of light that were absorbed more than others. Fabry concluded that there must be a substance in the Earth's atmosphere that was responsible for this absorption. He named this substance ozone, after the Greek word ozane, meaning to smell, as pure ozone has a distinct pungent smell. But Fabry's discovery didn't stop there. Through meticulous calculations, he deduced that this ozone was not uniformly distributed in the atmosphere, but rather, it formed a layer high above the Earth's surface. He had discovered the ozone layer. His findings were initially met with skepticism. How could there be a layer of gas so high in the atmosphere? But as other scientists conducted their own studies, they found evidence that supported Fabry's theory. They discovered that the ozone layer absorbed harmful ultraviolet radiation from the sun, providing a shield that protects life on Earth. Thus, the existence of the ozone layer was confirmed, but it would take many more years to fully understand its importance. As we fast forward to the year 2024, advancements in ozone layer studies anticipate significant improvements. The ongoing efforts of scientists around the globe are expected to our understanding of this crucial atmospheric layer, potentially leading to more effective strategies for its preservation and restoration. Transporting us back to the mid-20th century, when British scientist Gordon Dobson took up the mantle. Now, Dobson was not just another scientist. He was the one who turned the tables in our understanding of the ozone layer. His fascination with atmospheric physics led him to an invention that would revolutionize the field, the Dobson spectrophotometer. This wasn't your run-of-the-mill gadget. It was a precise, ingenious device that could measure the amount of ozone in a column of the Earth's atmosphere. Dobson's spectrophotometer was a game-changer. It used sunlight to measure the ultraviolet absorption by ozone, providing a direct quantification of the ozone layer's thickness. This allowed scientists to not only confirm the existence of the ozone layer, but also to monitor its changes over time. But Dobson didn't stop there. He was a man on a mission. He wanted to understand the global patterns of the ozone layer. To do this, he needed more data from more places. So, he set up ozone monitoring stations across the globe. From the cold, harsh landscapes of Antarctica to the sun-soaked plains of Africa, these stations diligently collected data, providing a treasure trove of information for scientists. This worldwide network of ozone monitoring stations, coupled with the Dobson spectrophotometer, was a powerful tool. It gave scientists the ability to track and study the ozone layer like never before. They could observe seasonal fluctuations, study long-term trends, and most importantly, detect any disturbances in the ozone layer. Gordon Dobson's work was monumental. His contributions were not limited to his invention or his network of stations. His true legacy lies in the scientific understanding he facilitated. He provided the tools and the data that allowed scientists to delve deeper into the mysteries of the ozone layer. Dobson's work laid a solid foundation for our present-day understanding of the ozone layer. So, the next time you put on sunscreen or admire a beautiful sunset, spare a thought for Gordon Dobson and his invaluable contributions. Because without him, our understanding of the world above us would be far less clear. However, in the 1980s, scientists made a shocking discovery. The ozone layer was depleting. This was not just a minor reduction, but a significant hole that had formed above Antarctica. It was as if our planet's protective shield had been pierced, and it was growing larger. This gaping hole was a cause for alarm, but what was causing this depletion? The culprit, it turned out, were compounds known as chlorofluorocarbons, or CFCs. Used extensively in refrigeration, air conditioning, and aerosol propellants, these molecules were a staple of modern society. But unbeknownst to us, they were also causing significant harm to our ozone layer. Here's how it works. CFCs are released into the atmosphere where they can linger for many years. Over time, they drift up into the stratosphere, where they are broken down by solar radiation, releasing chlorine atoms. It's these atoms that are the real troublemakers. Once free, they can engage in a destructive cycle, breaking down ozone molecules and contributing to the thinning of our planet's protective shield. This discovery shook the scientific community, causing a ripple effect of concern. The ozone layer, our planet's sunblock, was under threat. It was a crisis that demanded immediate attention and action. This discovery led to an urgent call for action to protect our planet's protective shield. In response to this crisis, nations worldwide united for the Montreal Protocol. This groundbreaking agreement, signed in 1987, marked a pivotal point in our battle against ozone depletion. The Montreal Protocol was a collective pledge to phase out ozone-depleting substances like chlorofluorocarbons and halogens that found their use in everyday products like aerosols and refrigerants. The result? A resounding triumph. By the dawn of the 21st century, production of these harmful substances saw a decline of over 95%. Fast forward to 2024, we are witnessing promising developments in the restoration of the ozone layer, attesting to the profound impact of the Montreal Protocol. Scientists project that if we maintain this trajectory, the ozone layer will likely be completely restored by the middle of this century. The saga of Earth's ozone layer is a testament to the power of scientific exploration and international cooperation. It's a story of a crisis averted and a reminder of the critical significance the ozone layer holds in sustaining life on our planet.